Hi, I'm ZISO, and today I'm going to get to talk about existential terror. I'm going to talk about the sheer terror of PAM, the Authentication and Authorization Framework for Linux and Unix systems. By the end of this talk, you should have a clear understanding of what PAM is, why it exists, why it sucks, and the horrors I encountered while writing a PAM module in Rust for work. Like I said, I'm ZISO. I'm a blogger, student of philosophy, and an aspiring fiction writer. Professionally, I work at Tailscale as the Archmage of Infrastructure, doing developer relations stuff. It's worth noting that I'm not speaking for Tailscale in this talk, but I am speaking about a project I worked on at Tailscale. Any opinions are my own. Authentication and authorization are two similar sounding concepts, but they are subtly different in ways that really set them apart. So that everyone's on the same page, here's my SRE Cliff Notes versions of the terms. Authentication is what makes sure you are who or what you say you are. This is why we use passwords, spicy hardware dongles that pretend to be a keyboard, and Google Authenticator codes. This only proves the identity of a person or a service, though. Authorization is what makes sure that you are allowed to do something. This is why you get those annoying user access control prompts on Windows or asked to scan your face to install apps on an iPad. The difference between the two is that authentication would be Kirby confirming who he is as the reincarnation of the god of death, and authorization would be making sure that Kirby has permission to recreate the world in his image. He would be authenticated as the reincarnation of dark matter, but he would not be authorized to use Stardream to reshape Planet Popstar to his will. Sorry for the major spoilers for like every Kirby game there. Kirby lore. Quite something. So, now that we know what authentication and authorization are, let's talk about the one library that everyone across most Linux distributions, Unixes, and Macs use for this. PAM. PAM is an authentication and authorization framework for Linux and Unix systems. It's not really one implementation, but they're all similar enough that we can just pretend they're one big happy implementation just to keep things simple. The biggest thing that PAM does that the things came before it doesn't is that PAM allowed for administrators to set up policies for how people could connect to computers. Today, this means that you can set up rules that match your buzzword compliant policies. PAM is the result of the 90s making the computer world a lot more complicated when multiple computers got into the mix. PAM came around after people realized that storing password hashes for everyone in the system doesn't work very well if you make the file with all the password hashes world readable. Computer security was a vastly different thing when the whole world ran on paper, eh? PAM was made by the Java people, Sun Microsystems. PAM was intended to help replace other competing implementations of tacky directory server integration, like shoving all of the password database into DNS, and get rid of the existing legacy cruft that had developed organically over the years. It's kind of amusing that PAM in all its incarnations is now the organically grown legacy cruft that it was set out to replace. As computers got faster at crunching numbers, they also got used more to store important classified work, so something had to give. Imagine how bad it would have been if hackers could grab your password hash over DNS and send it to a cluster of 4 whole PDP-11 mini-computers to crack it. PAM ships with a bunch of modules that let you check passwords against the local password database, run arbitrary commands on the system, check for account aging, and change your password. By the way, that change your password thing was something that I had a misconception about for a while when I was learning this. When I read the manual pages out of Ubuntu, I thought that those modules were for customizing the password checking rules, like the hashes and stuff. I admit I made an assumption based on incomplete information. This stuff is hard to research. But it turns out password modules in PAM are for changing your password, not for changing the authentication logic for using passwords. The FreeBSD Handbook helped clear that up for me. FreeBSD has amazing documentation, by the way. Check it out sometime. At the time, C was the best thing since canned bread, so PAM was written in C. Each module was implemented as its own shared library file, also written in C. And this worked great for the time that it was made for. It met all the needs, and it had extensibility by both system administrators and software distributors. It was great for its time. However, it's not the 90s anymore. It's 2022. Password theft is rampant. The computer in most display controllers on fancy laptops can rival the computers that PAM was designed for. Two-factor auth is mandatory for securing access to production. And to top it all off, somehow society has agreed that OAuth 2 and OIDC are decent standards. C has aged about as gracefully as milk in a desert, which makes it really easy to write arbitrary code execution bugs that also do something useful sometimes. But we still have PAM in every Mac, Ubuntu server, and all over the cloud. We will probably still have to deal with PAM for a very long time. And it's been around for about 25 years now, and the longer something is around, the longer it'll take to get rid of it. However, it's so ubiquitous that you can take advantage of this to make your servers do whatever you want on login. One of the really cool features about PAM is that every service on the system can have its own rules. When an application starts an authentication session with PAM, it supplies a service name. This service name is used to enable administrators to set up policies for that service in particular. At a high level, each service has a stack of these rules. Each of these rules tells PAM which one of the modules it should use and how it should react to what the module returns. It also lets you jump around the stack and then go towards whatever you want. You know, come to think of it, that reminds me of a language construct, but I just can't place my finger on it. Wonder what you could call it. There's an upside to this, though. Combined with service-specific configuration, this means that you can set rules like logging in with a password means that you need to use a Google Authenticator code, or when a login succeeds, log it to Slack or Discord, or even, if the user gives you a password, reject the authentication session and raise the alarm. With this, you can make it difficult to do the wrong thing. It's just really annoying to debug. Oh, you may be wondering something like, how do you debug this? Conveniently, PAM has login calls all over the place. But, additionally conveniently, they are all removed at compile time in most Linux distribution packages. So, the answer of how you debug PAM, stuff in PAM boils down to carefully. You debug it carefully. You know what? Here's the story of my first time debugging a custom PAM module. My goal was to try to make a PAM module for Tailscale. Tailscale is kind of like a VPN, not a privacy VPN. And one of the neat things about Tailscale IP addresses is that you have a one-to-one mapping of IP addresses and users. As a result, this means that you can use Tailscale as an authentication layer. So after some frantic hacking, I had this module, and from everything I could tell, it should have been working. I had it configured as an authentication module at the top of the stack. I made it put a "please God be working" message into syslog. I tried to make it print things to standard out. Nothing was working. So I started Googling how to debug PAM, and I got answers on forums from 2002 that mentioned classic Red Hat Linux and Slackware as if those were the only two Linux distributions that exist. Of course, what they said didn't work. So I needed a debugger. After looking over my options, GDB seemed least painful. I also kind of remembered using it in college, a decade ago. So I started the SSH server in debug mode under the debugger and then set a breakpoint for PAM_SM_authenticate, the entry point to my module. If I set this breakpoint, then surely I get debug access to whatever's going on at that point, I thought. I started SSHD and I tried to connect. Authentication failed. No breakpoint was triggered. Nothing useful except that GDB happily telling me that SSHD exited with status 0. The successful exit status. So I looked around some more to see if there was any decent documentation. I had to dig really deep, though. Really deep. I eventually found what I was looking for in a SunOS manual that was so old. It was an HTML frame set, remember those, in the Internet Archive. Somehow, only the content of the page was there, and the rest of the frame set was gone. But I got a bit of C code that would let me manually invoke all the steps that PAM did so I could test a module manually. It turns out that when you authenticate with PAM, under the hood, PAM calls the DLOpen call on the target modules in the configuration file. DLOpen is a C library call that lets you load a shared library file from the disk into memory, and then you can call functions in it as if they were functions compiled into the heckin' binary in the first place. Just like Java, Sun Microsystems, Java influence had to go somewhere. So what I needed to do is not set my breakpoint on DLOpen, but I needed to set it on DLSym. DLSym is like DLOpen, but it lets you get the address of a function out of a DLOpen handle so that you can run it. Based on past experience maintaining a tire fire of a chat server that uses dynamically loaded C modules everywhere, DLSym should normally be called just before the function gets called. I validated this against the little test program that the SunOS manual gave me, and everything worked. I even got the syslog calls like I expected. I tried it again with the SSH server, and I got a breakpoint. I win. I have a step in the right direction. So I asked GDB for the stack trace to debug further, and I get a bunch of useless function pointers. I was really confused at first, but then I figured out what was going on. Ubuntu strips the debug symbols from binaries in the packages that they release on their repositories. This will make your stack traces full of hex pointers instead of names. However, you can download the debug symbols and get all the names back. After remembering the right apt incantations, I was able to dig through the source code in parallel to the debugger session. After hacking around for a while, I got nowhere, but in so much detail. I put an SOS message off in a Slack, and I gave up for the day. Next morning, I woke up and checked Slack. A coworker had a suggestion, and it broke me a bit. But to understand why, let's look at the SSH server again. Ubuntu's default SSH server is OpenBSD's OpenSSHD. OpenSSHD doesn't ship with PAM support on by default because the OpenBSD people think that's insecure. I can't blame them. YOLOing in binaries off the disk, plucking functions out of them, and jumping to them while hoping they work is not safe at all. So they added a configuration option called Challenge Response Off that nerfs most of the fun that PAM can have. It's off by default in Ubuntu. Turning that on makes everything work instantly. It was that easy. It did everything I wanted. It even logged things to syslog. With all that in mind, let's go over the drawbacks of PAM's design that I've learned. Most of PAM's safety is predicated on everyone following the rules and doing things as safe as possible. When a PAM module is loaded into a service, the code in that module can't really assume anything about what's going on. It can't assume what user it's running as, what files it has access to, the network stack, or just anything. It gets worse when sandboxes and containers are in play. But in practice, basically every PAM service either runs as root or basically root. So this means that you can usually rely on having access to anything that root can, but if you're unsure, you kind of have to assume you don't. This is why I'm calling it as safe as an earthquake. If you follow the building code to the letter and you make absolutely everything perfectly correct, you're fine. If you don't, oops, the preschool building made out of asbestos just cracked in two with all the kids hiding in it. Good luck with that. One of my friends is a hardcore C advocate. He's made a bunch of things in C that nobody should try to make in C, such as web applications. This person also adamantly claims that C has a type system, so it's clearly safe to do this. Just one problem. I can't find any evidence of C having a type system outside of it just being numbers that the machine knows how to deal with and hoping everything goes okay. The epitome of this is the YOLO pointer, also known as the void pointer. A YOLO pointer points to some address in RAM. Where is it? In RAM. Does it contain anything useful? Hope so. How do you know what the data is? Look at it or just guess correctly. This works for function pointers too. You can make a pointer to a function out of a void pointer. In that one Games Done quick run of Ocarina of Time where they collect the Triforce, speedrunners just wrote their own function pointers with the control stick angle and buttons, because Nintendo wrote their games in C and they used function pointers all over the place. It was pretty cool. A wise friend of mine said that hope is not a strategy. But when you're dealing with YOLO pointers in C, hope is the strategy. PAM uses these everywhere with items associated with the PAM handle. This means that from a type system level, you can put the integer 42 into the remote IP address string field, and the compiler will be like, yeah, sure, whatever. But at runtime, you can get a seg fault out of nowhere if someone messed up. Most people do follow the rules though, so it usually works out. PAM was designed to have a fairly flexible configuration framework for systems administrators. But one of the things they did not do at the PAM level was make it easy to have third-party slipstream PAM modules into the main system without having to have deep knowledge of the PAM stack and everything it does. In practice, this means that each distribution has its own PAM configuration mechanism and base PAM configuration to deal with, and the documentation standards for how to do that can be poor. And by poor, I mean the only documentation is a design document deep in the archives of the Ubuntu Community Wiki. Thankfully, it was accurate, but realizing the only documentation is a spec is not a good feeling. When you are linking Rust code into C code, you need to be very sure that you are not leaking memory in any way. It will never be freed. Rust is usually good about not letting you leak memory on accident, but there are a few ways you can leak it on purpose. Don't. While I was off on my magic adventure into PAM land, I learned these lessons for dealing with PAM in the future. When you are writing security-critical things, it's best to be very careful about what dependencies you bring in. Keep the list small. If one of those gets owned, so does production. This can be bad. If you keep the scope of your PAM module small, you don't have to worry about scope creep. If you set out to do one thing, do that one thing and stop. Don't overthink this. If you need to do multiple things, write multiple PAM modules. Less is so much more. Using PAM in general doesn't let you make very many assumptions about service configuration stacks. Anything could be going on there. Using PAM on Ubuntu 22.04 lets you make a lot of assumptions about the stack. Plan for the today that is, not for the tomorrow that might be. In practice, you should not use handwritten bindings to any C library like I did when I implemented TailPAM. Use a tool like BindGen. They're there for a reason. Also, make sure that your code is fast. Authentication can happen surprisingly often. If authentication hangs, people can get worried. SRE adrenaline is a very powerful force. Be careful with it. In conclusion, PAM seems like a sheer terror at first, but really it's just a weird C library that everyone's standardized on. It's fairly easy to extend with custom logic in C or Rust, and it allows you to do whatever you want with whatever you want. It's the industry standard, and you've used it nearly every time you've logged into a Linux desktop. It's kind of terrifying, but at least it's everywhere. If you grab some random Linux or Unix off of the shelf, you can likely see PAM in there somewhere. Unless you're on OpenBSD. They don't use PAM. Before I get all of this wrapped up, I just want to take a moment to shout out everyone on this list for helping make this talk shine. Thank you all. And thank you for watching. I'm going to stick around in the chat for questions, but if I miss your question somehow and you really, really want an answer to it, please email it to rustconf2022@zserv.us. I'll have the written form of this talk up on my website soon, including my slide deck and everything I've said today. If you have questions, please speak up and ask them. I'm more than happy to answer them. Be well, all.